Okay, I've gone ahead and put up our first example here. What we basically have is we have, according to the book, we have a park here. It has two diagonal walking paths. They've already told you that PS is 180 meters and PR is 200 meters. They want you to find QT. Now T is the midpoint here where the two diagonals intersect. So what we've got to do is we've got to figure out how we're going to find QT. So we need to label everything, we need to get it on here, we need to figure out what we need to do to find QT. Okay? So what I would do is I would start taking your pen, I would take something and start putting these numbers on here. Start marking your pieces up according to what you know about rectangles, so that you will know exactly what's congruent to each other, what's equal, all that information, so that it will help you. Okay? So that's what I'm going to do. So the first thing that we know that PS. So PS is this side piece. So I know that PS, I know this entire side piece right here is the 180. So that's my 180. Now, I also know that PR, okay, PR, that's my diagonal. Okay? So that's my diagonal. So PR is this piece. That's the entire line. So that is the piece they gave me that was 200. So that's my 200. Of course, if it's 200, what do I know about each piece? Huh? It's 100. Because if the whole thing is 200, each piece is half. Okay? So let's remember this piece and this piece are congruent. So that means they have to be the same. So the only way it could equal 200 is if they are both 100. So that means this piece would have to be 100 and this piece would have to be 100. So I just went ahead and broke it down. It was easier to put that than to write 200 for the whole line. Now I also know that this piece has to be equal to this piece. Now why would I mark that line? Why would I mark anything on this line? Because QT is the one I'm looking for. So that's got to affect it because that's the line that's got the information I need to find. QT is up here. So I know this QT is equal to whatever this one is. Now at this moment, really that's all I know. So, can anybody think of anything else that I know that I may not have put up here?
You still didn't divide it.
Didn't divide what?
Because if X, yeah, if Q and S are split into two pieces, and 100 was the whole QS, don't you gotta divide 100 by 2 to get QT?
Say
Or is QT
QS?
just 100?
They didn't mention QS. They told us what PS is, which is this side. And they told us what PR was, which was 200. So this whole line was 200. So if the whole line was 200, then this half was 100 and this half was 100. So I've already split that. But I don't know anything about this line, because they didn't tell me anything about this side.
Okay.
But now that's what they want me to find. Now, what do I know about rectangles? Well, we know the sides are congruent, opposite sides are congruent, but is the side really going to help me with the diagonal? No. So, focusing on these opposite sides is really not going to help me. It's not going to help me solve these diagonals. Let's focus in a little bit on the diagonals. My shape doesn't lean. My shape doesn't do anything. It's perfectly the same everywhere. Okay? So, what does that tell you about the diagonals? Would they be the same? In a rectangle, they would be. Just like in a square, they would be. Your shape is perfectly the same everywhere. So, what you need to know is that in a rectangle, your diagonals are exactly the same. I'm going to say congruent. So your diagonals are congruent in a rectangle, because your shape doesn't lean, which means one is not going to be bigger than the other. In a perfect rectangle, both diagonals are going to be exactly the same length. So if one diagonal is 300, the other diagonal is going to be 300. That's something you've got to remember. This right here. That's going to help you. So, if I know that my diagonals are congruent, do I really have to do anything? No. Because I know that if this diagonal is 200, then what do I know about this one? It's also 200. So what does that make each one of these? 100. All because I know that in a rectangle, okay, now make sure you understand, that's a rectangle. Because if it leans, they are not necessarily going to be the same. One may be longer than the other. But in a perfect rectangle, both diagonals are going to be exactly the same. So what do I know right now then about QT?
That is 100.
That is 100. I didn't have to do any work. I didn't have to do anything. Now, I could solve it by using a problem, an equation, and solve it. But as long as I know this, right here, I don't have to actually do anything. This is going to be the key for some of you. You better write it down and you better make sure you know. So does that make sense? Now it may be the same for a square. We'll have to wait and hold on to that one tomorrow. So make sure that you pay attention. So let's try another one. Now we've got some in just a minute that we're not going to have a choice but to solve. But if I can get around it by using what I know, That's gonna help you. So let's try another one. So we've got another rectangle, so draw another rectangle. Draw some more diagonals. So technically we're using the exact same problem, we're just looking for something different. So we've got P, Q, R, and S again. We know T is still in the middle. Now, what they're telling us this time is that TS is going to equal 120 meters. So they want us to find PR. So we basically have the same shape again. Now, we're not bringing over the information that we had from the last problem, we're just recopying the shape. So don't bring over that 180, don't bring over the 200 because that's not applying to this problem. Just bring over the picture and now use the new numbers, which is the 120. So what are they telling us this time? They're telling us this time that TS, that's this piece, right here, is now 120. So if I know that this piece is 120, what do I know about this piece? It's also 120. Because these two pieces are congruent, so I know this one is also 120. Because I know they have to be exactly the same. It cuts it in half. I know that the two pieces have to be exactly the same. So, what does that tell me about the entire line here?
240.
The whole entire line is 240. So, what does that tell me about this line of PR?
Is that the diagonals are the same?
They're the same, so PR is also 240. I didn't have to do anything except use my brain. Because I know that this diagonal is the same as this diagonal, so once I find this one, I automatically know what this one is. So use what they've given you to apply it to the second one. Does that make sense? Okay, because if you have to do this on your own, I don't want to hear, I didn't know where this came from. How did you do that? Okay, now they want us to look at an angle. Okay, so now we're going to forget about the diagonals and we're going to go to looking at angles. So, we're going to use the same shape again, but we want to look at the angles. So, I mean, I can just leave this drawing if I want to. And down here, I'm going to give you what I know. What I know is that angle, the measure of angle PRS is 64 degrees. So instead of having to redraw it, I'm just gonna leave it, and we're going to use the same shape here. So that's what they're telling me, is that the measure of angle PRS is 64 degrees. So they want us to find the measure of angle SQR. We want to know what that equals. Now, first of all, what do I know about every angle? They're 90 degrees. I know that every angle in this rectangle is 90 degrees. So I'm going to go ahead and put my little boxes here, because I know every angle is 90 degrees. So now, PRS. Where is PRS?
Hold on a second.
Huh? If you were doing angle PRS, which one would you be doing?
The left side, no?
Here's P, here's B, here's R, and here's S. The middle letter tells you which one you're dealing with. So you're doing P, R, and S. So that's talking about this part of the angle right here. Okay? So that's what I'm dealing with, is this one. So I'm hunting, or they're telling me, sorry, PRS, they're telling me that this piece of the angle, right here, that I just shaded in, they're telling me that that is what?
64.
Okay, they're telling me that that is 64 degrees. Now, how is that going to help?
Because you can subtract 91
Okay, well, hang on. Let me do this. What am I looking for?
SQR.
Okay, SQR, which is where?
Q.
Do what I did a while ago. SQR.
Let me go for Q.
So that's going to be this piece. Not the entire angle, just that little piece. So you're looking for this piece. So you're looking for that little piece that I've got shaded in green. Okay, now let's use a little common sense here. What do I know?
Oh, no.
You don't know. You don't know anything?
The opposite angles are congruent.
Okay, so opposite angles are congruent. So, what is that going to tell me?
The two angles are supplementary.
Okay, so which two angles are you talking about?
SRQ and
So S, R,
Q.
Q. So you're talking about all of this.
No, I meant to say P.
SRP, so you're talking about this angle and which one?
RQS.
RQS. So you're telling me that these two are?
The one next to 64.
This?
Yes, it's the opposite angle as Q.
So you're telling me that these two are?
Yes.
Well, if they're on the same side of the rectangle, what are they? They're supplementary. Would they not be?
That's what I said.
Okay.
Oh,
Because you said something about opposite angles. Okay. So you're telling me that these two are gonna add, right? Okay, so how's that gonna help?
They both add up to 90.
Okay, so all we gotta do then is,
Subtract 64 from 90.
okay, so we need to subtract this 64 from 90, and it's gonna tell me what this is,
26.
okay? So, we are taking this 64, and we're subtracting it from 90. So 90 minus 64 is gonna leave me with 26. So that tells me that this angle right here is 26 degrees. So now, if that angle is 26 degrees, then what?
Angle
Q.
Q is 26.
Then angle Q is also 26. That is correct.
so how do we know that they were supplementary?
They're congruent angles. They're consecutive.
Well, what did the rules say? What was it that we talked about?
You talking about the diagonal?
They said that angles on this side have to add up to equal 180 degrees. We didn't talk about that today. We either talked about that on Friday or we talked about it yesterday. But consecutive angles in a parallelogram have to add up to be 180 degrees. That's why you got 90 here and you got 90 here. Because they have to add up to equal 180 degrees. Right? Okay. We also know that opposite angles are also
180.
congruent. Right? Okay, so if we take all these pieces that we've already learned, then we should be able to weave them in here somehow. Right? So, look at what you got. If I've got this angle, I know that this one is 90, this one is 64, so I should be able to find that one, right? So that one would have to be what?
26.
Okay. So now, do the same thing over here. So, I would know, again, because these two form a 90-degree angle, number one, that this one would have to be 26. Right? Okay? So, if I knew this one was 26, like we just talked about, right? Remember? This side's 26, that side's 26. If this side's 64, this side's 64. So now, I've got this angle over here. So, all I gotta do is finish filling in the rest of it. So again, Look at what you got. This has got to be 90. So I could even go in this direction. So I mean, if you keep turning this paper long enough, you're going to figure things out. Are you with me?
I know, I got it.
Okay. Because, I mean, that's all we're doing, is we're talking about complementary, supplementary, and filling things in. So, I mean, I could sit here all day and just keep going and filling my angles in. But you've got to learn the rules yourself. So, again, every small angle that I've got, say I've got a small angle here, I got a small angle here, I got a small angle here, I got a small angle here. Every one of those is going to be 26. So they're all going to be the same. So any other questions? Okay. Well, let's see what we got on the next one. So the next one, we've got another rectangle, but we're going across the page this time. So on the next one here, let's go across the page. So we're going to go across the page this time. So we've got J, K, L, and M. Draw your two diagonals, and where they intersect is going to be point P. So draw your two diagonals, where they intersect is going to be point P. What you know, what you're given is going to be the measure of angle KJL is going to equal 2x plus 4, and I'll slide this over in just a second. And the measure of angle JLK is going to equal 7x plus 5. We want to find x. So we've got our rectangle. Here's what I know, and there's what I want to find. So we can go ahead and we can mark what we know. So what do we know again about our rectangle? I know this is congruent to this, and I know this is congruent to this. What do I know about my angles? I know that they're all right angles. Okay, so I know that much right now. Now, I also know, according to what they've told me in the given, I know what? That KJL. Where is KJL? Here's K, here's J, and here's L.
So we're gonna find J.
Huh?
Or we're using J.
It's going to be this little angle right here. This little angle right here that I colored in orange. That little piece right here is this top one that they gave us. So that's going to be the 2x plus 4. So this is my 2x plus 4. where is JLK? Where is JLK? Because here's J, here's L, and here's K. So it's where?
L.
It's down there at the bottom. It's L, which is this little angle down here. So this little angle down here that I colored in red is my 7x plus 5. Okay. Now, what do we know here that we can use? Now, what you might need to do is think back to when we did the lessons before where we talked about the parallel lines and cut by the transversals, and we had to name all the angles. And you know, you had to talk about alternate interior, alternate exterior, those kind of things. If I said that you had this line up here that's parallel to this one, which we know is true, and it's cut by this transversal, this angle is congruent to what angle?
L.
This angle, right here, is going to be congruent to
Beside the L.
this one. Because they are technically alternate interior angles. This little piece is going to be congruent to this little piece. So now that would leave this piece, the 7x plus 5, that piece to be congruent to this one. Because they would be alternate interior. They're on opposite sides of that transversal. So these two are on opposite sides. So they are congruent. These two are on opposite sides. So they are congruent. So what does that mean then?
That means they're both at an equal value.
That means these two would be the same. These two would be the same. So technically these two then would be what?
Complementary.
They would technically both be right here, and they would both be
90 degrees.
right here. So they would both add to be 90 degrees. That's what you got to remember. So I could technically write that right here. Whichever color I had here, I don't remember. So I could put, since these two were the same, I could put another 2x plus 4 right here. Since these two were the same, I could put another 7x plus 5 right here. So now they are both side by side in this corner, so they would both have to add up to equal 90 degrees.
So do we
So now just set it up that way. So now all you got to do is say, and it doesn't matter which one comes first, 2x plus 4 plus 7x plus 5 equals 90. And then of course all you got to do is solve. And you have a calculator for that, so you shouldn't have a problem with it.
I got x equals
X equals what?
9.
That's correct. Because when you combine these, you should have got 9x plus 9 equals 90. So then when you subtract 9, you ended up with 9x equals 81. So now divide by 9, and x does equal 9. But you've got to remember that not only are they congruent, but they're also parallel to each other. So, question. Does that make sense? Do I need to re-explain? What do I need to do? Because I don't want you leaving saying I don't understand what in the world she just talked about, how she even set that up, because it didn't make any sense. Because if you've got a question, I need to know. Because you are going to have to do some of these. So everybody's okay. Okay, let's see what you can do with the next one. I'm going to let you have this one. And we're going to see what you can do. So on this one, you've got a rectangle. Again, going across the page. It is labeled as JK, L, and M. You've got your two diagonals. Where they intersect is point P. Now this time, you are going to be told that JP is 3y minus 5. And you are told that MK is 5y plus 1. So I need you to find y. So let's see what you can do with it. Keep your mouth closed. Don't be sharing any answers. Don't yell anything out. So we're going to see what happens